All right, guys, so properties of numbers is today's first lesson. So here we go. For our vocab, all right, the first word is properties. Everyone?
Properties.
All right, so the font's really small, so listen carefully. If you need me to, at the end to you can't see a word, let me know, and I'll make sure that I clarify it. So here we go. Your book says properties are statements that are true for any number. Okay, statements that are true for any number. So in your little box, go ahead and write down properties are math rules. Math rules. A lot of properties you guys already know about. I mean, maybe you don't even know the name of the property, but you know about the rule and what it means in math. So they give fancy names to them and call them properties. All right, our next word is, and oh, by the way, there's two things that will pop up this year. You'll either have a little asterisk, meaning a little star next to the word, or you'll have the words, the phrases in quotes. What that means is this is not in the back of your book. It actually may not even be in your notes. Those of you that are looking and have no idea where they are, that it's probably because it might not even be in your notes. However, the reason why we go over it is this is popping up in your homework today. So of course it's pretty important vocab word. And it'll pop up on tests and quizzes too. All right. It just doesn't happen to be in the book. All right. So here we go. The next property is commutative property. Everyone?
Commutative property.
All right. So your book says that this is the order in which numbers are added or multiplied does not change the sum or product. Okay. So what that means is this. Here's an example. 6 plus 9 is equal to 9 plus 6, right? We probably have already known that. That is called the commutative property of addition. Why? Because the two numbers are being added. There's also another one. This is the commutative property of multiplication. 4 times 7 is equal to 7 times 4. Okay, you'll get the same answer either which way that it's multiplied. Okay. However, if you notice, no subtraction or division there. Commutative property only works with addition or multiplication. Okay, if you guys have questions, write it down on your paper and I'll answer them as soon as we're done with this part of the vocab. All right, here we go. The next property is called the associative property. Everyone?
Associative property.
Okay, so the associative property, this is the way in which numbers are grouped when added or multiplied, and it pretty much property says that it does not change the sum or product depending on how they're grouped. So here's what it means. So for example, okay, 3 plus 6 plus 1. If you have parentheses or if it's all addition and you have the parentheses around the 3 and 6, it's going to be the same as 3 plus 6 plus 1, but if the parentheses are around the 6 plus 1. That also means that if you don't have any parentheses, it's just also saying that you can add the first two or the last two. You can even add the first and the last one first. It doesn't matter as long as it's addition. You can add them in whichever order you want. You'll still get the same answer. Okay. Same thing can be said about multiplication. If you have 5 times 9 times 2, you can multiply the 5 and 9 first, or even the 9 times 2. Think about it with this, right? 5 times 9 is 45. 45 times 2 is what? For some of us, 90. That might be kind of easy for some of us. But look at this one. 9 times 2 is 18. 18 times 5, well, maybe some of you know. Well, now we know it's 90, right? But it's easier to go 45 times 2 than it is 18 times 5 sometimes. Okay, so that's why these strategies work, because you can sometimes use them to your advantage as a nice property, as a rule. Okay, here we go. What you'll probably want to write down is this. Okay, we're going to be, during this lesson, use the charts on page 19 and 20. Okay, you're going to see a lot of properties, and that's where some of these properties are. So in your book, 19 and 20 are going to be your best friends. Okay, when I'm not around, and if you don't have parents or older siblings or anyone around to help you, then you need to know, there they are. Okay, here we go. Now, something that's going to pop up, and this is in your notes, right? There's no quotes around it. Okay, is counterexample. Everyone?
Counterexample.
Okay, some of your homework's going to ask you to give a counterexample, and we'll get to that eventually, but here's what it's going to be talking about. This is your book definition. An example that shows a conjecture is not true. Okay? So here's what a counterexample is. Proving something is wrong. So usually if you're proving something is right, you would give an example. Oh, 5 plus 4 equals 9. Let me show you with using little marks on the board. But if someone goes, you know, Mr. Wilkins, 2 plus 3 is 6. You say, no, no, no. It's not. Let me give you a counterexample. And then you could actually prove that it's wrong. Okay? So that's kind of what that means. We'll take a look at that during the lesson. All right, here we go. Simplify, everyone. Simplify. All right, simplify. We kind of talked about this earlier, right? To write an expression in simpler form. To write an expression in simpler form. Smaller answer. That's pretty much what it means. Simplify it. Make it a, I put quotes around it because sometimes simplified answers are not always smaller, but you can kind of think of it that way. Smaller answer. To simplify something, an expression, also like we talked about earlier, can mean like to solve an expression. Okay, here we go. Something called deductive reasoning. Everyone? Deductive reasoning. Your book says that this is the process of using facts, properties, or rules to justify reasoning or reach valid conclusions. So it's almost like backing up your statement by saying, well, this is what this property says. Okay, that's what it's talking about. So using different strategies for an answer. That's sometimes when that comes in handy. Using different strategies for an answer. All right, I know that's a lot of vocab in one shot, but it is in your book, and we're going to come across it in our homework. So, all right, I know a couple hands were up. Questions? Did I answer them already then during the lesson? No questions? Okay. All right, here we go. Let's go to our examples. So, remember what I just told you guys, what you might want to do? Grab your book, all right, take out a piece of paper, but you might want to keep your binder open if you want to fill in a couple of words from this lesson with book pages, right? It's up to you, though. I'm not going to make you, but it might be a good strategy. So go ahead and grab your book. Okay. Turn to page 22 is where our problems start. Remember, the lesson starts usually a couple pages before. Page 22. Okay. And then also, you'll want to take out a piece of lined paper and put your heading on there. All right, eyes up here as soon as you're ready to go. Remember, it's on page 22. If you're wondering, we're on that first one right there. You can turn to page 21 and 22 if you like. The first problem we're going to do is on page 22, though. All right, first and last name at the top. Period. Your period. Put the date. Put the assignment number, book pages. All right, here we go. First problem we're going to do, take a look at problem number 16. Okay, this type of problem on your homework tonight, it will say, state whether each conjecture is true. Here we go. If not, give a counterexample. So there's some of your vocab right there. All right, so here we go. Here's what it's really talking about. 16 says, division of whole numbers is commutative. Okay? So the first thing you probably want to do is take a look at some of your key words in there. It's talking about, of course, division, and it's talking about the commutative property. Now, if you don't remember, of course, well, hopefully all of you know what division is, right? But if you don't remember what commutative is, then use that chart. Remember, commutative property, it doesn't say of addition or multiplication, but commutative property means that, like, 4 plus 6 is the same as 6 plus 4, right? Or 2 times 5 is the same as 5 times 2. Okay? Well, this one says you can use it with division. Well, when we looked at the properties, it's only, remember we talked about it, it's only multiplication and addition. Okay? So this is, I can write, step 2, once you take a look, this is not true. Not true. Now, the third thing you're going to want to do here is give your counterexample, meaning prove it wrong. So, here's what I'm thinking. 6 divided by 3. What's 6 divided by 3? 2. How about 3 divided by 6? Good, yeah, think of it as a you could think of it as a decimal and do the division if you want, but you could also think of it as reducing a regular fraction. It's 1/2. It's not 2, it's 1/2. These are not equal to each other. There is your counterexample. Okay, remember we talked about proving it wrong. All right, questions?
Can you just show our work by just saying not true and then giving a counterexample?
Exactly. So guys, remember, steps are only for what we do in class, just for notes for you to look back on. But if you take out all the steps, that's all you need to show. Well, on these problems, there's no work to show. It's kind of researching it, finding out the facts, okay? And then, of course, just giving it a counterexample to prove it wrong if you know it's not true. So yeah, it's just write in the answer, basically, on these problems. Any other questions? Okay, here we go. I'm going to give you guys, it shouldn't take very long. I'll give you guys 30 seconds. Go ahead and same page, try out problem 14. 30 seconds, go. Okay, anyone need more time? Okay, go ahead and finish that up. Okay, while those people are finishing that up, I want to talk class strategy with you, and this is very important if you want to have less homework. Okay, if you are a person who got done in the time that I gave you, but I'm still giving a little extra time, use that extra time to your advantage. Now, you have a whole set of those kind of problems there. Okay, that might or might not be on your homework. Okay, but if you do have some of those type of problems on your homework, do those while the other people. That way you're getting your homework done during the lesson. Okay, so do that. Use that extra time to your advantage. Okay, just checking in. How many of you still need more time? Okay, I'm going to introduce one new thing to you guys today. All right, that we'll be doing in every lesson. All good lessons are going to have this. Okay. I'm going to have, and we've talked about this before, I'm going to have you guys pair up to discuss your answer. And then if you guys disagree, you'll be able to back it up with examples or counterexamples, right? So here's what I'm going to do for right now. Okay? These two rows, you're going to partner up with the person to the side of you. And every once in a while, someone will be absent or someone doesn't sit there. For right now, the three of you guys will pair up. Just don't leave anyone out. Bring that third person in, okay? So every 2 rows, these 2 rows, you guys are partnering up across the aisle together. All right, I'm okay with you guys, one of you guys scooting closer to the other person or taking that step closer. That's okay. All right, these 2 rows, you guys are side by side pairing up. Same thing with these 2, and same thing with these 2. And again, the row, guys, if you need to, get a little, one person scoot their chair over and show and talk about it. Okay. I'm only usually going to give, unless it's a real long problem, multi-step problem. I usually only give you about 30 seconds. Listen, when you share, if I don't expect anyone to do this in this class, but if you share and you guys disagree, okay, I've actually had students in the past that have been like, no, it's this, and they think that they're going to back up their answer by getting louder. Okay, that doesn't work. Okay, back it up with facts. Show them proof of what you're talking about. Give another counterexample if you need to. Okay, talk about it with that person because that's only going to help them understand it better. Okay, any questions? All right, 30 seconds. Go ahead and share your answer with your neighbor and talk about it if you need to. Go.
I got not true because, well, odd numbers always have one more, so, and ultimately odd number you get one
All right, sometimes at this point I'll go ahead, and I haven't introduced these to you guys, but these little popsicle sticks here have numbers, these beautiful little numbers on them, and those numbers, that's your desk number. So sometimes I will pull a desk number and I will ask you for the answer. Depending on how much time we have, I like to do that, and then we can talk about it as a group. For today though, I'm going to show you and then just compare it with what you guys have, and then I'll let you guys ask questions, okay, if you don't have what I have. All right, so here we go. Number 14 says, the sum of two odd numbers is always odd. All right, so we're talking about odd numbers. Okay, I'm just doing step one. Key words here. Odd ends up having an answer of being odd. All right. Well, I'm thinking not true. Why? Because right off the bat, oops, I guess it'd be good if I put true. Not true because, why? 3 is odd. 5 is odd. Sum means addition. Does that give us an odd answer? No. Nope. There's our counterexample. There we go. Now your counterexample, you're not psychic. Right? It doesn't have to be exactly like that, but it should be similar to that. You should show two odd numbers that equal a positive number. I'm sorry, an even number. All right, questions, guys? Okay, here we go. Next type of problem. Let's go ahead and flip back over to page 21. Let's take a look at problem number 4. Okay, it says name the property shown by each statement. All right, so number 4 says 9 plus 3 plus 20 equals 3 plus 9 plus 20. All right, now when I'm looking at this, rereading it, it says name the property shown by each statement. It's not saying is there a property, right? So it's saying that this is a true statement. We just got to back it up with what the property is. So here's what I always tell my students, and there's a number of different ways, but on this particular one, I'm going to look at both sides and ask myself, what's different in the two? Well, the difference is that 9 plus 3 is 3 plus 9 over here. Okay? 9 plus 3 is 3 plus 9 over here. So what that means is I can take two of them and switch them, and it give me the same answer. They are equal to each other, these two sides, even though 3 and 9 are flip-flopped around the addition sign. Okay? Well, again, what I can do is there's a bunch of properties. We talked about some properties in our notes. There's properties on page 19 that are highlighted along with the chart on 20. Okay? Use that to your advantage. I already know that you could flip-flop two numbers around an addition sign and give the same sum because that is commutative property of addition. Here's what I'm going to do. Commutative of, I'm going to just put, oops, I guess I would put of, that's a bad of, sorry. cursive F, of addition. Now I do want to say something. Step 2 is find out the property, but step 3, ladies and gentlemen, don't forget to say if it's of addition or multiplication. Okay? Because commutative property of addition and commutative property of multiplication, even though they have part of it the same, it doesn't mean it's the same. I have a lot of students in my classes that have the same first name, but what? Different last names. Same kind of thing. So make sure you clarify which one it is exactly. Okay? So step 1, take a look, kind of analyze both sides, right? Really look at it, break it down, find out what is the difference. That will usually help you find out what the property is. Write the property, and don't forget if it has, I'll put a little star here because if it has something like that, you'll need to include it. Okay, questions? All right, I'll give you guys 30 seconds because this is, you're going to know it or you're not. Go back to page 22, take a look at problem 18. Okay, problem 18, go. Bless you. Okay, anyone need more time? Okay, a couple of us. You're probably kind of looking at the charts. That's okay, I'll give you a few more seconds there. Maybe about 15 more seconds. For those of you that probably already realized that this is not a property that was in our, it's probably a rule that you know, but it's not a property name that was in our vocab, right? So that's why I wanted to point out those extra charts in your book. So use those. Those are your friends there. Okay, just checking in. Anyone need more time? We're okay? Okay, 30 seconds. Listen, if you need to back it up, show the person where you found the answer, okay? If they disagree with you. Okay, 30 seconds. Turn to the same partner and go ahead and share. Go.
I got the search too. I love school.
Okay, I heard some good conversations out there. So, if I go through the steps, and I kind of strategically chose this because step 1, if you remember right, I said most of the time this will work. Compare the two sides. Well, this one, we do compare the two sides, but this is saying all of this is just equal to 0, meaning that these numbers are all multiplied with that 0, and it creates 0. Well, the property that is they call it, if you take a look on the chart on page 20, okay, that is, they call it, and there's always a couple of different types of names for these properties, okay, or just, they basically have the same root word, okay, but, oh, am I doing the wrong problem? Yes. Oh, okay. So, I'm doing problem 22. So I tell you what, go ahead and do 22 with these. Is that your homework? Yeah. So I'm giving you the answer right now, so do it with me, and then we'll come back to number 18. If you take a look, this was in the chart, okay? This was the multiplicative property of 0. If you don't want to write the word property, that's fine. Hey, my mistake. You guys got a freebie there in our lesson. So good job. Didn't have to even do anything. again, if you don't write the word property, that's okay, because we understand that they're all properties. You could just, for the sake of our homework, put multiplicative of 0. I've heard people call it the zero property of multiplication. That's another one. So those are called different things. So number 18, let's do the one that you guys did where you can check it. Okay, number 18 is, actually it's kind of very similar, right? 0 plus 14 equals 14. What's the difference in the two sides? Well, 14 is the same. This one's just being added to 0, meaning that anything added to 0 is 14. Well, that is kind of the addition version of this in some ways. I'm sorry, 0 plus 14 is itself, I should say. I don't know if I said that wrong the first time. So this is the additive identity property. So when you're adding something to 0, it is equal to 14. It stays the same. There's actually a multiplicative identity property, or identity property of multiplication. You guys probably already know the rule, right? What do you need to multiply a number by to get the same answer on the other side? 1. Yeah, it's a little different than the addition part, but yeah, if you multiply something by 1, you get the same answer on the other side. So that's the multiplication, or multiplicative identity property, or identity property of multiplication. All right, so just gave you some extra stuff there. So here we go. Any questions, guys, on, well, either one of those, especially the one I had you guys do with your neighbor? Okay, one more type of problem. So let's stay on page 22. Let's take a look at problem 28. So here's what they're wanting you to do on these problems. If you take a look at the directions, it says simplify each expression. So in problem number 28, this time I'll be more careful and put the right one down. 14 plus, and then in parentheses, is 27 plus m. So they want you to use a property to your advantage. They want you to use a property to help you solve, or at least simplify the problem. Okay, you're not going to be solving anything right now, but you will simplify it. So here we go. Simplify the expression. So here's what I need to do. The only thing I can simplify here, okay, you could say this is step 1. What can you simplify? Well, the only thing I can simplify are these two numbers, okay, are those two numbers. So the problem is that according to order of operations, we need to add these two first, right? Because there's where the parentheses are. But there's a little property called associative property of addition, meaning that we can move these parentheses over. So step 2 is rewrite the problem to help yourself out. I'm able, 14 plus 27 plus m is the same as 14 plus 27 plus m. Just by moving the parentheses over, we can actually solve those two instead. So I guess you'd say this is step 3. I'm going to go ahead and solve. So 14 plus 27. Well, 7 plus 4 is 1. Carry the 1. 2, 3, 4. So it's 41. And then, of course, we rewrite the whole thing. And we're not going to be able to simplify that. We'll talk more about that in the future. But that's our simplified expression. And that's all you have to do on these problems. You don't have to state, that doesn't say anything about stating the property. Just use the properties that you know of to help you out. Okay. All right, any questions on that one?
On our homework, do you need to write out step 2, all that?
Those are just your notes. So if you get stuck, those are a little thing. Maybe you can look back.
So if we can do it in our head, can we just write the last part, or do you need to write the whole
on this type of problem, I'm okay with, if you're adding 14 plus 27, you know the property that you can do that. So you've done this in your head. I'm okay with that if you're adding these two numbers first. Okay. It doesn't ask you to write the property of what you're using though, so that's okay. All right, guys, any other questions? Okay. You may have seen it already. Go ahead and try out problem 30. Problem 30. I don't think it'll take longer than like 30 seconds to do that. Problem 30, go. Okay, does anyone need more time on that one? Okay, a few more seconds there. Again, guys, there's a lot of those problems, so if you're done with that, don't drop your pencil. Get going on your homework. This is the last type of problem, so if you're comfortable with all those, you can probably do almost all your homework at this point, okay, until we're ready to share. Okay, just a few more seconds and then we'll talk about this. Okay, 30 seconds. Go ahead and turn to your neighbor and share. Go.
I got 8s in parentheses times
1. All right, here we go. Step 1, I'm taking a look. The only two numbers I can multiply, right, are the 8 and the 9. It's all multiplication. So guess what? If it's all multiplication, I can use, actually, if you want to get critical here, I mean, you would do something like, you'd use two properties. Okay, and not that you had to write this, but I'm just showing you. I can flip-flop s times 8 here and use commutative property of multiplication. And then I can turn around and move the parentheses over, meaning I would just be multiplying the 8 times the 9 first. I'm using associative property of multiplication. So you're kind of almost using two different properties. Okay, but in the end, I have s times 72. Now listen, I'm going to be picky here. Okay, I want you to start, if you ever have a multiplication with a variable and a number, I want you to start writing the number in front of the variable. We have to start getting used to that, making it into a coefficient. So s times 72 becomes 72s, and that's our answer. Guys, just looking for this because this will get you ready for the next level, as well as future problems. Okay, questions?
What if we just put the 8 and the 9 in the times?
So if you, what I'm saying, that's what I'm saying earlier. So if you just did all those two in your head, kind of like we were talking about earlier, and you just did, okay, I did right here, you went straight from 8 times 9 to 72 times s. As long as you end up with 72s, I'm okay with that. Okay?
Okay, so you say the answer used to be 72s, can it be 72 times s?
No, guys, I want you to stop, because when you have a, it's kind of like when you have a, when you have, let's say 8 times 9, you guys have seen that, right? Like a number next to parentheses. That means multiplication. So I'm just, like I said, we're going to see a lot of this in the future. When a number is right next to a variable, right next to a letter, that is also means multiplication. So just start trying to get used to writing it like this. Okay? I mean, does 72 times s mean the same thing? Yes, they have the same value, but this is what you're going to be seeing more as you go through middle school and high school, even through advanced math. Oh, you mean like around here?
Yeah.
Get rid of parentheses. Because this is, like I said, 72s is what you're going to see. Okay? I know, guys, that, and it doesn't mean that it means has a different value. It means that it's going to be expressed like this as we go on through the year. Okay? And I know we haven't gotten there yet. But I'm trying to, why worry about this later on when we could worry about it now, and we'll worry about the harder problems, the meat of the harder problems later. Okay. All right, guys, any others? Okay.